So, what we're going to talk about is Field-Marshal, which is a platform as a service, which is deploying your node on the internet. So not really writing web services in Node, but doing other stuff with Node. We're going to run through this and we're going to talk about what Field-Marshal is and how it do. And then we're actually going to do a live deployment that will hopefully work. Because it didn't at SidJS. So if you saw this talk already at SidJS, you saw me fail. Hopefully tonight it will be exciting because you'll see me succeed. So, a quick aside, these slides are all WebSockety enabled. So if you want to go there on your phone, the slides will actually real-time update with the power of Node. So that's fun. Really handy for anyone with a vision impairment, or not a problem here, but if you get stuck behind a column or something and you can't see the screen, that's a nice thing. It's all built into Reveal.js, which is the framework that I use for presentations and a lot of people use. So if that's a thing you want to do, you can do it. So, who am I? I'm Dave. G'day. I haven't been before, but gonna get up and tell you how to write Node anyway. I co-founded Pinion. We put ads in video games. We do things to people. I also consult. So if you need a hand with nodeJS, or I do a bit of front end work as well, you can give me money, and I will do that for you. So that's very briefly, obviously, JavaScript on the server. I'm assuming if you're here, you kind of know what Node is. But the nice thing about Node that I'm going to sort of delve more into is that it lends itself well to a service-oriented architecture. So, rather than writing, a monolithic app like you might in Rails or, in ASP, which, is fine. I'm not here to crap on that. Node lends itself really nicely to writing sort of a whole bunch of decomposed tiny little services. So, if you've got one service that does one thing and another service that does another thing, rather than them being sort of modules or different sections of code within your app, in Node it's much easier to write those as completely separate applications that will talk to each other over HTTP, or that will talk directly to the client, individually. So that's kind of a property of Node that makes, what I'm doing kind of make more sense. You want to run a distributed group of many tiny services that each do one thing really well. So, in the new world, everything is cloud-based. Everything is cloud all the time. Everything has the same name that has cloud in it. And we kind of need to deal with that. So this has given us some new acronyms. There was IaaS in the beginning. So IaaS is exactly like your computer, only somewhere else. This is infrastructure as a service. So you can buy like a virtual machine, or even a dedicated machine that you can get quite cheaply and quite quickly. But it's basically just the same as your local machine, only in a data center somewhere. It's a bit slower. You don't care if your disk breaks because it's somebody else's hardware and it's not your problem. We then kind of moved on to PaaS, which is platform as a service. And this is kind of like a single purpose computer, if you're not familiar with it. So instead of a whole computer that you can run 12 different things on if you want, a PaaS is platform as a service, which is you can deploy some code to it and it will run that code. It won't be a full-on interactive computer environment that you can deal with. You can just say, here is a repository of code. The PaaS will run this piece of code for you. So managed deployments, simple scaling. The nice thing about PaaS is you can quite easily say, all right, you're running that bit of code really well. I want you to run it 6 more times, because I got tech crunched or whatever. That's a nice thing that PaaS allows you to do. Really quick and easy scale up and scale down, so long as you're willing to pay them for it. Go along. Yes, so definitions are out of the way. We're going to briefly talk about use cases, where you would use all these different things briefly. And then smugly, we're going to talk about the PaaS I wrote in JavaScript, because I'm proud of it. It might get a bit smug. Use cases. You should be using an IaaS when you need lots of flexibility. All right, so it is a whole general purpose computer in the cloud. You can do anything you want on there. You can run ASP.NET, if it's Windows, I guess. I don't really know much about ASP. You could run Rails on it. You could do all kinds of stuff. If you need to run 6 different services on the one box, maybe that's a thing you want. If you want your database on the same machine as your front end, maybe that's a thing you want. If you've got the skills and the resources. So IaaS, you need to care about security. if you get hacked, you're going to look dumb. So you want to make sure that all your ports are locked down, that all your services are, watertight. Because if you don't, it's possibly going to end badly for you. You also want AWS if your app is monolithic. If you've only got one process that runs your whole app, it doesn't really make a lot of sense to go to a PWS because you can get that deployed on AWS fairly simply. It's not going to be that hard. So if you're running a monolithic app, maybe this is fine. Maybe you don't need to go into the extra complexity. Also, if you just love Chef, if you just love writing Chef recipes, that's all you want to do all day, you should use AWS because that would be good for you. Yes. So in the beginning, we kind of ran all of our services on manually managed, dedicated, and VPS computers. So we did kind of transition into AWS, but we're still doing everything by hand. It becomes an unmaintainable mess really fast, because everything's done by hand. Only one guy knows how to do things. Maybe you've got some shell scripts floating around. It takes a really long time to onboard anyone into this process, and as soon as you want to make changes to it, it gets kind of hard. So then you go configuration management. You take those shell scripts or that knowledge that's in somebody's head and you kind of bundle it up into Chef or something similar that says, essentially here is a list of steps that the computer will then run to bootstrap itself up. And that's good. This is a good place to be. If you get to here and that works for your app and your organization, then great. You're doing all right. There's no need necessarily to go down the extra complexity unless you need it. Easy to add capacity because you can only say Chef, create me 6 more machines so long as your hardware provider can do it. Easy to recover from failure, but generally just a giant pain in the sack, I found. Writing the Chef recipes takes a lot of time, takes a lot of energy, not super flexible always, and especially with a service-oriented architecture, if you just want one little service that just does one little thing and it's like 20 lines of code, to then go and write like 100 line of code Chef recipe just to deploy that, it's gross. I don't like it. So you kind of go from there and then you start looking at PWSs, platform as a service. So I don't want to write all this deployment code. I don't want to put all this effort in. I don't want to care about the security of my servers. I want someone else to do that for me. So you look at PWS, you look at Heroku, you look at nodeJS, you look at some of those providers. And really handy when you just want to focus on your code. All you want to do is write codes. I don't care about deployment. I'm very happy to pay you some money to do that for me. Brilliant. They will do really, really, really simple scaling for you. You can call nodeJS or Heroku or on the web obviously and say, give me 10 times what I've got right now, and that will just happen, and you don't even need to think about it. And that's amazing. But all of that convenience and all of that somebody else doing this stuff for you obviously comes at a cost. You've got to pay them to do that. And it also comes at a cost of a bit of transparency. I don't know if you're familiar with maybe 6 months ago now, Rap Genius kind of blew up at Heroku because their routing policy wasn't as they'd advertised. They said that we're routing things to your servers this way, and actually they were doing it a totally different way. It's a reasonable thing from a technical point of view, but they didn't tell their customers that. And as soon as you're putting your code on somebody else's servers and paying them to maintain it for you, you're kind of beholden to that. You trust them, you put a lot of faith in them, and they don't always do that. So it's got to be a better way, I thought. Went through a whole bunch of past vendors and all sorts of stuff. Fantastic simplicity until you hit that brick wall. Until you want to know exactly how your routing's done, or until you want some particular package installed on there that they don't have, or you want to do something in a slightly different way. You just can't do that. There's no, oh, maybe I can do a bit of that. It's just no. The past vendors do things in a particular way, and that's it. So as soon as you hit that brick wall, you're kind of stuck. Like, where do you go? So I got real mad, and I wrote some code. And what came out of it was Field-Marshal. It was, kind of the largest yak shave I've been on in a little while. I wrote a lot of code so that I wouldn't have to write like a little bit of code in Chef recipes. So, question my intelligence, but I've already done it, so you don't have to. So that's cool. My goals were for it to be open source, so that's easy. It's MIT licensed, do what you want. For it to be robust, I've got a bunch of tests. It's on Travis CI, so you can see the little green flag in the GitHub repo. For it to be simple, I say I wrote a lot of code, but it's actually across all of its units about 1,000 lines of CoffeeScript, so it's not that much. There's not much going on. If you want to sit down and read the code base, you can do that, and you can get a sense of how everything hangs together and how everything sort of occurs. And for it to be portable, the idea of this is that you kind of become your own little Heroku, and you be your own little Heroku wherever you want. You go and buy some machines from Amazon on their EC2, you go and buy some machines from Linode, you go and buy some machines from Rackspace. I don't care. Go and deploy Field-Marshal and any of that stuff. How you want to do your load balancing is up to you. The idea of Field-Marshal is that it does what it needs to and doesn't care about anything else. It's up to you to do that however you want. So obviously, you can go chase the best deals, do whatever's going to work for you. Importantly, being Australian, you can run this inside Australia if you want, which, unless you want to run, say, Rails on Ninefold, you kind of can't do anywhere else. If you want to pass, you've got to go overseas. And if you've got a latency sensitive application, or if you care about data security, you're kind of out of luck. So, nice thing about Field-Marshal, I think, is that it's declarative. So, we're kind of getting more hands-on with it now. This is a little example of the manifest specification for Field-Marshal. So this is how you tell Field-Marshal what you want it to do. The idea is that you've got, sort of a whole bunch of computers. You don't really care how many you've got. You don't really care, where they are or what takes place. You just want to say to Field-Marshal, I've got this code. I want you to run this much of it. And then it will figure out where and how, and, you don't need to think about it, which is kind of the PWS dream. So here we're telling it, all right, I've got this piece of code called MOTD. It's one of our internal packages. I want you to run 3 instances of that. Maybe you want, maybe it can't maybe one alone can't handle your traffic. Maybe you want a bit of redundancy, whatever. I want you to run 3 instances. A few other things, like it's an internal parameter, so that you say it's about this heavy. It's going to cost you about this much resources as compared to my other apps, because maybe this thing takes a lot more effort to run than my other things. So you can give them arbitrary load values. You then give it some options. Now, this is written in Node, and we're going to be talking about Node, and all the stuff I do is in Node, but Field-Marshal doesn't care if your code is Node. Like, it's not my problem, man. If you want to put sort of rack up in that command array, go nuts. This will run whatever you've got installed on the machine and whatever is in your code repository. I don't care what you write your code in. Everything is Git-based, so you can give it a commit char, or you can just tell it, run the latest thing that I've pushed to you. Whatever the last thing was that I pushed to you, run that. And that gets you that kind of Heroku style of deployment. So if you've got some more code, you just git push, and it will go, oh, I've got some new code now. And it will go and deploy it out, and it will go and shut down the old ones. You also give it environment variables. So this is how you pass in sort of configuration options to your application. This is a very common thing in the PWS world, and this is one thing that you might not be kind of used to if you're not used to dealing with PWSs. If you've got, say, like an API key or a password or something for an external service that you talk to, maybe you put that in like a JSON file, that's like options.json, or maybe you just hard code it into your code. That's not great. You don't really want to do that because then it's in your Git repository. This is a way of getting, all those secrets or all those sort of per machine, whatevers out of your code and out of your source control and into somewhere where, it's distributed less. So kind of key here is the random port, because you're not going to start this thing on port 3000 or port 3004 because you don't know where it's going, you don't know what's happening. You just want to tell Field-Marshal, start it on whatever the heck port makes sense for you. And then Field-Marshal will figure out how to get your traffic from the outside world to this application. That's all taken care of for you. So you just say, all right, whatever port you tell me to start on, that's where I'm going to start. You got some setup options as well. So if your program needs something to be done before first run, like say npm install or gem bundle, I don't know enough about Ruby to talk about Ruby, but whatever setup options you've got, that's a thing that can be done. Or run those setup jobs before first run of your application. You also then give it routing. So you say when somebody shows up to the front load balancer looking for motd.pinion.gg, that's what they want. It's this thing that they're after. So that. Oh, I've ruined it. I've ruined everything. That's what I wanted. So on the load balancing, this is kind of the topology of it. So you've got users and clouds and lightning bolts and satellites and stuff. They will then come into a load balancer. This is your problem. I don't care what this is. For me, I use Amazon Elastic Load Balancing. You could also use round robin DNS. You could use whatever Linode does. I don't care. All I care about is that traffic is reasonably evenly distributed across the cavalry slaves. If you want to send it all to one, that'll work, but obviously you'll get more load on this guy than on any of these guys. So these cavalry slaves are the computers that actually run your code. So in this setup, we've got 3 slave machines and 1 controller. So the Field-Marshal controller is the one telling each computer what to run. Then each of these cavalry slaves is actually running your applications, your codes, your whatevers. So the idea is that you can direct a request to any one of these, and it will then internally route amongst them. So if I request motd.backend.pinion.gg, and that's actually only running on these 2, but my request happens to end up on this, it'll internally proxy it transparently, so that the request still gets where it needs to go, everybody's happy, you don't need to care what machine is running what. All right, now we're going to go to the demo, and we're going to hope it works this time. So the setup for this is we've got 3 Ubuntu machines running on AWS. This is all that I've done to them to get them to the stage they're currently in. So kind of like nothing up my sleeve. All I've done is install nodeJS, Nginx, Build Essential, and Git. So just some really base packages that come out of the repositories. We're going to go the rest of the way right here, right now. So the idea of this is that if you wanted to, you could go home and you could set up a PWS all of your own. All right. So first thing is this is the Field-Marshal machine. So this is the one machine that's going to control our 2 slaves. So what we're going to do is install Field-Marshal. So it's just an NPM, it's just a standard NPM thing, and it will go and do. Then we're going to install Cavalry on these 2. So again, just an NPM package, nothing fancy. If you've used NPM, that's very familiar. Going to install some deps. Going to install some deps. It's eventually going to install some deps. So these machines in the AWS data center, this isn't happening on my laptop. You'd think the internet connection would be a little bit quicker. I think NPM has been having issues the last couple of days. Talk amongst yourselves. Has anyone got any questions so far? Does anything not make sense?
There's command line up, the pre-run options, it looks like you can only have 1 command there.
Yeah, you can have multiple. So that's an array. That.
So you just have an array of arrays.
No, so that they just get concatenated together. So if you wanted, sorry.
Setup one.
Yeah, they're the same thing. So if you, it's just Unix, right? So
Okay.
yeah, if you want to concatenate things together, you can do that.
Why is it tokenized?
Sorry?
Why is the arguments in the command separate a superstring?
Because that's how Node expects it from memory. I think it's something to do with exec or yeah, exactly. Yeah, so
There's an array of arrays there, so I could have command.
yeah, you possibly could. Yeah, I don't know.
I can actually send you a pull request for that because in DocPad we have a library that handles that because say for NPM and Node they can be in different locations and depending on the path, especially on Windows we have lots of problems with
Yeah.
Node not being detected.
Yeah.
So we have a library to always figure out the correct place for it.
Yeah. Yeah, I mean the nice thing about this is that your environment should be pretty sane. It's a different use case to DocPad where it's like, hey, go and run this on like your crazy laptop running Windows 3.1. No, this is like for data center machines that you should be able to set up. What am I doing?
So I wanted to ask how you found
Yeah.
Because you're proxying through machines.
Yes.
What's the performance like on that?
Look, you do pay a penalty. You know, I'm not going to lie to you on that. But in practice, I've not found it to be that bad. So if you're super latency sensitive, you know, maybe you should do it a different way. You know, what you could do is hook into it somewhere and get the ports that the individual services are running on and then speak directly to the service.
You could expose that service availability.
Yeah, that's totally possible. Field-Marshal, like the master, holds a table of all things that are running on all ports.
Yeah.
So it's pretty easy to query for that. So, you know, if that's the thing you want to do, sure. All right. All the packages are installed. So what we're going to do now is write a manifest file. Yeah, we'll stick ourselves in a subdirectory, just keep things clean. We're just going to vim manifest.json. We don't actually want to run anything right now. We're going to run some stuff later. So right now it's just an empty array. Syntax highlighting. Just an empty array, nothing in there. What? No, not insert mode. Alright. Yep, good. Good. Alright, good. So now we're going to start Field-Marshal. Obviously in production you would want to be doing this in an init script or, you know, an upstart job or something that's going to restart it if it crashes or your machine goes down. There are templates for that in the repo. For now we're just going to run it as a process because you can if you want, that's fine. So we're passing in some configuration options here, a password, the host name of the machine that it's running on, and another password. All is clear in the docs. Fingers crossed. No. All right. There's a reason for that, and it's because I'm dumb. Manifest.json needs to be in a subdirectory. So it could actually be, you know, rather than manifest.json, we could make it nodeninjas.json, and that would be fine. So, come on now. Yes, all right. So Field-Marshal is started, but there are no slaves. So it's whining that, look, there's no slaves available. If you give me jobs, I can't tell them to run anywhere. So let's give it some slaves. These are the two cavalry machines. And we're going to start a cavalry slave. So, getting a slave ID, which is just, you know, the sort of friendly name for this machine. It'll just use a host name if you can't find one. We're going to tell it where the master is, so where it should be checking into, and the password to use to check into that master, and the password to expect when it gets, you know, past jobs. So, yep, happy, good. Yep, because that has checked in. So we'll check in the next one. Same thing, it's just we're calling this one 1B instead of 1A. Yeah, do that. Cool. So we now have a platform as a service running. It's done. We did that with one master and two slaves. So that's all fun. Whatever, Dave. Let's push some code to it and make things happen. So what I have here is, you know, I'm just in my repos directory, just a test repo. Very, very simple little node HTTP server. So all it's going to do is listen for all connections on whatever port it's told to, and then just respond with a 200 and a little bit of text telling us about itself. So, cool. Git push up to the master. It's called test1, and we're pushing branch master. Cross your fingers. Yes, that's gone. So, that code is now, we pushed it up to our master machine, and the master machine has automatically pushed it out to both of our slave machines. So that code that we've just git pushed from my laptop here is now on 3 computers in the AWS Sydney data center. So, cool, it's got the code, it's not running it yet, like whatever. Yeah, that should work. So, let's tell it to run some stuff. Here is one that I mostly prepared earlier. I wrote it already. All right, that's already running. So the app is called Test1. This is a magic value for instances that says, look, I don't care how many you run. I just want you to run one on every slave that you have. The domain that we're going to use to query it is test.nodeninjas.com, which is something I've just written into my hosts file to save DNS propagation. So when I go there, it will show up. When you do, it won't. There's no setup for this, so just echo so you don't whinge. The command to start it is node server.js. Latest commit, don't care what it is, just whatever the last thing you've got is, and on a random port. So, yep, good. So, it spawned at least one of those things, which is nice. So let's visit it with a web browser. I prepared this. Hey! 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 So, this is the test1 repo on that IP, which is one of those machines that we spun up. That's pretty cool. Now, if we keep refreshing this, we told it to run one on every machine. So this particular bit of code should be running on 2 machines, right? Because we've got 2 machines, we said run on every machine. So if we refresh this, that IP should change. Should change. It's not changing. That's embarrassing. It's getting there. Look, we're halfway there.
Is it because of the ports just pointing to that one slave?
No, because of the magic of internal proxying. So it's the way that we've got the router set up is it's just doing least connections. So it'll go to slave 1, and that'll then have 1 connection in Nginx. And then the next time the request comes in to that same slave, it'll go, okay, well, slave 1's already got 1 connection. It's me. Slave 2 has 0 connections, so I'm going to internally route that off to slave 2. You can give, that's all done by Nginx, so you can give that other rule sets if you want. If that's not what you want, then tell Nginx to do a different thing. But by default, that's the way that it should go. No, okay. All right, it's a different IP now. That's fun. It changed, honest. So, cool, you've made a PWS that runs 1 bit of code. You know, you haven't really gotten far from like a chef recipe on an IWS from monolithic app, whatever. So,
It could just because you're running it in the same tab and it could be just a persistent.
it could be cached, yeah.
Maybe.
It's not persistent. Well, yeah, let's try curling it. Let's get crazy, man. Let's not just get the headers, because that's dumb. Yeah, there you go. Look at that. James was right. It's because he's a clever dude. So you see 50% of the time, because it's on least connections, it's going to different IPs. So we have a thing running 1 bit of code. It's not very impressive. Let's make it run multiple things, because our architecture is service-oriented, right? We've got a lot of different services that we want to run all at the same time. So you can have these manifests in different files if you want. Just for clarity's sake, I'm going to have them all in the same file here. Don't get your JSON wrong. What? Yeah. Good. Good. So this is test 2. It's a different repo. We actually haven't pushed yet, so we should push that. No, because I'm not foregrounded. Okay. Because very cleverly, I only have 1 session to the master open, and I've stalled that session to play with Vim. So hang on. That's some Unix arcana. But there you go. It's done. It's done now. Cool. Yeah, what? Yes. Good. Right. Good. This is riveting, right? Watch a man write correctly formatted JSON. Cool. Done. All right. So test 2, different repo. Same code, except that it tells you it's test 2 instead of test 1. That's a nice thing. Start the master up again. Yeah? Oh, yeah, that's bad. Let's restart it. Yeah, I totally wrote malformed JSON, didn't I? Probably not. What extra brace? Yeah, no, that's not meant to be there. That's why the indenting was failing. Yes, good job. Keen eyes. Right. What? Yeah, good. So, if we now go to test 2, we're running the test 2 app. There's 2 apps running. Hey? You can run test 1 and test 2. And test 2 is also running on multiple machines. So that's good times. We'll go back to our curl test to prove that. Yep, different IPs. So look, it's the future of clouds. Cloud lightning clouds. That's all I got. Questions? Abuse?
So there was a project at Yoko called NodeJS that tried to do something like this, and then they got bought out by Appful.
Mm-hmm.
And then NodeJS is dead now. How is this compared to NodeJS?
I've never played with nodeJS.
Okay.
This is built out of a project called Fleet, which is Substack or James Halliday, because I tried really, really hard to use Fleet in production, but it was just too gross. It was something that James sort of hacked together quickly and then abandoned for other things. Like exactly, that's his deal, right? So he went like a really different direction with like really integrated DNS stuff, which is super cool, but is not what I wanted. So I did this, which is a lot simpler and hopefully a lot more robust.
Yeah, because with NodeJS, like the install instructions were like gigantic, and it took me like after a few days I just gave up.
Yeah.
So,
Yeah, well, I mean, that's all the things. We've just done all of the things. So that's the install instructions. Yeah, so there was a guy just behind you. Yeah.
I was just going to say, like, do you have plans to extend this to say, have a interface where you can actually move the instances up? Like, in this case, you've got those instances already running. So that's probably one of the distinctive things that sort of, like with Heroku, you sort of like, that's taken care of. But have you got plans to do that and write just bundles that may work against AWS or some other cloud?
Yeah, totally. So the way of spawning new apps is just interacting with JSON. So that's kind of like a separate app. I may build, it's not much code, so I may well build that into Field-Marshal itself. You can post some JSON to it, and it will incorporate that. What I should show you is Quartermaster. So this isn't for the little test one that we just had. This is our production setup. So hopefully it's not on fire. Well, that's going to be embarrassing. So this is in production. We run, a bunch of stuff. That's on fire. Damn it. So you can see here it's running more instances than what I've specified. That's a known issue that I'm working on fixing. It's not a terrible thing because it's just more of what you wanted, but it's dumb. There you can see, we've got a couple of slaves. These are all the processes that we're running. It's a little Angular app, so you can Angular all over the place. So yeah, it's the kind of the philosophy for tooling with Field-Marshal is that everything is just HTTP and JSON. So I may build some tooling into it, or you can just build your own tools and talk to it via cores. Like this is if you want to run a Quartermaster instance, don't just use quartermaster.pinion.gg because it's a static site. All of this stuff is just stored in local storage. There's no server involved. It goes and talks to whatever Field-Marshal server you tell it to here directly and handles that via cores. So, it's kind of more of this service-oriented architecture stuff that everything is a separate unit and they all just talk to each other.
Did you ever look at Amazon's main store?
Yeah, it's weird. I tried to grok it, But like with all the Amazon stuff, they have kind of their own way of doing things. And like I love a lot of Amazon products, but Beanstalk just didn't make sense to me, so I got bored and walked away. It might be great, I just don't know. Anybody else? You good? Yeah.
I don't want to kind of ask a pushy question.
No, go for it.
But how well supported do you see this being in the future? Like, is this something that you've got a roadmap for that you're planning on? I guess you kind of answered that one just now because you're actually using it in production yourself. But yeah, like, is it kind of done, or?
It's done in that it is currently good enough to use in production, so I'm now kind of in bug fix mode, and little bits of tooling that, would be nice. Like Quartermaster is good for sort of seeing what's going on. It would be nice to be able to just push up jobs in kind of a nicer interface than just write some JSON. So right now, it's going to be supported for my use case. If I personally stop using it, if you send me an issue, I may fix it because I'm a nice dude. But it's an open source app. I'm not making any money from this. But you always have the option to pay me to fix whatever issue you want. That's a thing you can do too. It's a standard open source line. But pull requests happily accepted, money for code happily accepted.
What did it say when you didn't have the slaves, by the way?
Oh yeah. So I haven't actually pulled in that PR yet. Oh, I pulled the PR, but I haven't submit. I pushed it out to NPM. NPM. Yes. So in head, it's a much funnier message than what it is there. Yeah.
Are all the communications between like the master and the slave secure? How does that work?
Yes, kind of. No is the actual answer to that question. So the masters and slaves authenticate themselves with HTTP basic auth. So you can't just send arbitrary commands to one of my slaves and have it do it. You've got to know the secret. The actual traffic, no, is sent in the clear. It's just pure HTTP. If you wanted to use HTTPS and encrypt that, it's not going to be very hard. It's just that obviously you then need certificates and stuff that are going to be trusted by both your systems. So that's cool.
Web traffic that's by default unsecure, obviously.
Exactly. Yeah. But in most use cases, this is going to be set up for. You don't really care. Like if they're all in the same data center, that's layer 3 or above routing. I trust that Amazon is only sending the packets to where I sent them to. There's not going to be a hub in the middle of Amazon's switching gear, I hope. But yeah, if you wanted to use HTTPS, it would be pretty trivial to do.
Okay.
Cool.
Could you build a Heroku client on this?
Well, I don't use a lot of Heroku, so I mean, what more functionality do you want? Like their build packs and stuff are pretty full on. Zero downtime deployment is kind of hard. This is pretty close to zero downtime in that Nginx will sort of transparently shift across the connections. Like pull request and away you go. But yeah, I'm not particularly interested in competing with Heroku in a business sense. Like I'm happy to write code that does what they do, but I don't want to try and take their market. That's too much work.
Because for probably just talk to you.
Yeah, cool.
So is it just Nginx that will route anything if something fails?
Yeah, so it's Nginx doing the routing, and that will obviously look for hosts that are down. It'll say no, the last thing I sent to that guy failed. I'm not going to do that. So yeah, all that kind of routing magic is within Nginx. It is fairly modular though, so if you wanted to use something else, you could. I think it'd be nice to have something in pure Node, so that it's one less dependency to install, and then you can use Nginx optionally if you need the extra performance. But cool. I'm gonna let the robot guy talk because I want to see his underwater robots. Thanks everybody.